We're showing here in this picture the 9000 timer assembly. The setting that we have on this program is the white dot is opposite the 39 on the label. That would give us a 3,900 gallon setting. Looking at the label, it's represented by times 100. This would be our start point, the white dot opposite the gallons capacity arrow. This also, if you take a look down here where the manual regeneration knob is, the white dot is opposite this arrow here, and we're in the service position. As we use water, the meter gallon wheel will start winding itself down until 0 will be opposite the gallon capacity. At that time, we would initiate a regeneration. When swinging out the timer assembly to expose the program wheel, we have to again remember to remove the meter cable from the meter in the back of the unit. Otherwise, we can pull out the clutch assembly right up here in the upper right-hand corner. When we swing out the timer assembly, we fully expose the meter or the program wheel so that we can make our different settings for backwash, brining, slow rinse, rapid rinse, brine tank refill. The key thing in this photograph, we want to take a look at these two micro switches down in the lower right-hand corner. The inner micro switch, the one closest to the timer housing, is our homing switch. The outer micro switch is our program switch, and that's what tells the drive motor which position to go to for backwash, brining, slow rinse, rapid rinse, and brine tank refill. Now let's go through the cycles of operation. And again, let's just run the unit through like it was counting gallonage and initiating a regeneration. Our mechanical meter cable is going to be turning our meter program wheel that we had set for 950 gallons. It's going to keep counting gallonage till we hit that 0 point. And you'll notice at that 0 point, there's arm and a little leg here that come in contact. When those two come in contact, if you hear that little click, it's starting up our timer motor. Now let's just swing this timer assembly out and we'll show you what's happening. As we zeroed out that meter, we're pulling that inner micro switch way on the inside out of that little notch position. And remember I said that notch position was our home position. When the micro switch is in that position, no power is being used at all, no electricity. We bring it out of that home notch, we start up the timer motor, and now it'll advance. Now there's a gap in here from that position, from the notch to the first set of pins. On the 1 minute per pin or hole, it represents 9 minutes. On the 2 minute per pin or hole program wheel, it represents 18 minutes. Now this is a lag in time. On domestic applications, really doesn't have much of a bearing. But if you're running on a commercial application where there's a constant flow rate running at all times, you should take this into account when setting up your reserve capacity, either a 9 or an 18-minute continuous flow, because nothing actually happens until we hit that first set of pins. And those first set of pins, remember I mentioned, was our backwash cycle. Now what I want you to take a look at is that when we hit those first set of pins, we're going to key in and watch these two gears, the top and the bottom gear. I'll rotate this timer then, and you'll notice that the bottom gear starts moving. That bottom gear is attached to a lower piston, and what's happening is we're switching tanks. So the first thing that happens is we switch tanks. As soon as the tanks have been switched, the top piston will start moving, and we'll put the unit into the backwash cycle. Now that tank switching and the piston that does the switching of the tanks is on the outlet port of the unit. So that when the piston's in one position, one tank's on stream, and in the other position, the other tank is on stream. But when we make that tank's transition, we're opening up both tanks for a short period of time and then making the complete transition. But in this transition, there is no pressure drop, flow drop, or pulsation in the line. It's a very smooth, even type of transfer. Also, there is no hard water bleed by or leakage that occurs when the tanks switch. You'll notice now that the top piston has stopped. And if we rotate, we'll just move this over to the side. If you look around to the right side of the control valve, you'll see that there's a label here and a top arrow and a bottom arrow. The top arrow tells us which cycle the unit is in. The arrow is now pointing to the backwash position. The bottom arrow points to which tank is in service. In this example, what we're running through right now, the bottom arrow is pointing to tank number 2. Now, tank number 2 is always our tank with the adapter base on. Tank number 1 is always our main valve. So in this condition, tank number 2 is in service. We're regenerating the control valve. Swing this back. We're going to advance the timer off that first set of pins into our brining and slow rinse cycle. You'll notice that only the top gear assembly moves. We've made our tank transition. It stays in that position until the end of the cycle. We've pushed it into the brine draw. Now we're drawing all the brine out of the brine tank. When that air check in the brine tank shuts off, then we slowly rinse it out. The timer will advance until we hit our second set of pins. That second set of pins, again, is our rapid rinse cycle. We'll ride up on it, and you'll hear a snap or a pop, and that's the brine valve falling off a cam assembly. The rapid rinse cycle is like a downflow purge. We're flushing out the system of any impurities or anything that's left over after the brining and slow rinse. Advance it a little bit further into that 6-minute brine tank refill. Again, only the top piston moves. And we can pick out any one of those positions again on the right side of the timer with that upper arrow. Takes a little while for it to make that transition, usually about 5 or 10 seconds. Once it's stopped, we have 2 sets of micro switches, one off this main cam and the micro switches that are on the timer. Those sets of micro switches have been used on many of our other controls for many, many years. The switches are rated for a 15 amp service. At the most, we're drawing a fraction of an amp. Now we're going to ride up on our 2 stop pins. We're done refilling the brine tank, and now we're going to bring the unit back into the service position. Now, once we drop off those last 2 sets of pins, I want you to watch the top and the bottom gear assembly. Because for a moment, for a few seconds, both will start up and start rotating. And then stop. What's happening there is we're repositioning the top and bottom gear assemblies so that we're all set for the next regeneration cycle. And if you take a look, if we can kind of tilt this back here, you'll see right at the bottom of this gear assembly, there's a cutout or a notch. Because we're only running one piston at any one time, and remember the first thing that happens when we run on those first set of pins is we switch units. That bottom gear assembly rotates until we hit this like neutral position, and that's where that little pinion gear kind of sets throughout the entire regeneration. But when we're done with all the regeneration cycles, we want to get those gears meshed back together so that the next time the meter zeroes out, we repeat the process again. And that's why we have that slight little jog at the end to mesh the gears together, and we're all set to go. The timer motor will keep running until we hit that home position right here. And now the timer motor is shut off. All the water running to drain should stop. When cycling the 9000 valve out of its home position, the first thing that's going to be observed is this lower gear unit and piston assembly moving. Because the first thing that happens is that we switch tanks. And again, remembering the piston assembly is on the outlet port of each unit. There is no flow drop, pressure loss, or hard water leakage throughout this transition from tank to tank. Once we've switched tanks, the top piston assembly starts moving and it'll be driven into the backwash position. Noting in the upper right-hand corner here, you see these red micro switches. We have two micro switches there, and those flip-flop power back to the timer assembly. The key to the 9000 switching tanks is this little star wheel right in the center of the two gears. This is called a Geneva wheel. It's used in precision tooling, in which you have a multiple bed table and indexing it from spot to spot. We use this to bring the lower drive unit in first, switch the tanks, and then once that takes place, we start the top gear assembly into the regeneration cycles, so that really we're only driving one piston at any one time. In doing so, we can get by with a much smaller drive motor. Again, taking a look at the two micro switches up here, the outer micro switch to the left is our homing switch, our program switch is the inner switch.